Hello, and welcome to Stockholm Hardware number 14. This time it's on lighting. We have 3 main talks tonight. Åsa, over here. Hey, Åsa. Malin, and Lars. And we were also planning to have Max and Mikael do some lightning talks, but they couldn't make it. They're both sick with some kind of winter flu. And I've got a little extra bonus with me. This is one of my daughters. Hey! Here's the agenda. I'm not going to stick around for too long, as you could imagine. And I think Åsa and Thomas is going to take over. But we'll probably organize it like this, do the 2 main talks, then do a break, and do another talk after the break. Yeah, that's right. If anyone wants to do a lightning talk, so this is like a demo or some kind of talk there about something you're interested in, you're more than welcome to come up. It's max 5 minutes. So if you are interested in that, just come up and talk to Åsa or Thomas or Caroline. And that reminds me, Caroline, during the break, do you want to just come up for a moment? I think, Caroline, are you okay to do a tour of Stockholm Makerspace?
Yes, I'm happy to do so. So Stockholm Makerspace, for those of you who have never been to Things, is located right at the bottom of this house. And it's 300 square meters, and it's got tons of really cool hardware equipment. So you are welcome to join if you've never been. And if you have been and you still want to join, then you're welcome to do that too.
Cool, very nice. Yeah, so we're going to do about 15-20 minute break, and that should give you enough time to check out Makerspace downstairs. I already briefly mentioned Åsa and Thomas over here is 2 co-organizers for Stockholm Hardware. And I'm going to take off for the rest of the evening, and Thomas and Åsa and Marek is going to run the show. So have a good night.
All right. So how many people have been here before at the meetup? More than 50%. All right. So what the meetup is all about is building a strong hardware community in Stockholm. It's already pretty strong, but we try to promote this and make it even stronger. And we are on all kinds of levels. Many people are engineers, many people have more creative backgrounds. Some people have both. We work in small companies and big companies, so it's a bit of a mix of all kind of backgrounds. And which is pretty cool, because then we get to meet each other. So try to take a chance to talk to somebody new, maybe during the break, because it's always fun talking to new people with new backgrounds, really. We're not for profit. We don't get millionaires out of this, too bad. We don't even try. We're all volunteers. So in terms of logistics, there will be food. There is food downstairs already, I guess. See people eating. There is drinks as well. And I think there are something like 200 beers, and we are like 50 people, so it will be a good night, I guess. There will be a break where we can go to the bathroom, but we will also see the makerspace. The bathrooms are in there. And the cameraman, Marek, is here. Woo! And what we're doing is we're making a live stream to Facebook, I guess. So everything we will do will stay out there forever. So we have to behave. Forever on YouTube. All right, great. And then what you can do now is people can stream it on Facebook, but you can also see it later, I guess. It will be there on the YouTube channel after the event, right? Yeah. All right. The partners of the meetup is Stockholm and Things that organize the whole thing and provide the food. And we have the volunteer today, Raphael, who is probably working because that's what he volunteered to do. So tonight we will have 3 people talking, and I don't know what's happening with like disease and stuff, but 2 people got ill, and so we will have a bit of a shorter thing. But we have 3 people, so we expect to end around maybe like 8:30 maybe. But before that, going into the main talks, we'll have some community announcements related to hardware and what we're doing. And there was at least one guy who wanted to talk about the upcoming event. Yeah, and maybe there are more people, so you can just come up and we can... you want to say something as well? Yeah, cool. Yeah, I saw it, yeah. So, Sweden Demo Day.
Hello everyone, I'm Federico. I'm working on the organization of Sweden Demo Day 2017. It's the main matchmaking event in Stockholm. It will take place in Münchenbryggeriet on December the 12th. It's a great opportunity to meet new investors, partners, whatever you're looking for, networking also. And you will have the opportunity to pitch on the stage and to be part of the Startup Expo in the main hall. For this edition this year, we are working hard in order to facilitate also high-level one-to-one meetings. We have a tool to do that. It's Launchback. You can find about it on our website. So it's not a Slash or a web summit yet, but it will be in Stockholm. It's free, 100% free, and community-driven event. And so, I don't know, if you are looking for an opportunity to meet new people and opportunities, sign up. The website is swedendemoday.com, and I will be around, so if you have any questions, I'm here. Thank you very much.
Thank you.
You didn't get a slide, but you have
I don't?
a line.
Sune told me I have.
Did he?
Yeah.
You got a line on the slide show.
Okay, I got a line now. Well, that's something, at least. Hi, I'm Stina from Things. I think what I wanted to announce is that we, at Things, we have been organizing in a project, actually, called Ignite Sweden. I don't know if any one of you heard of that. During this year. And on this Thursday, we actually have the grand finals of the project, where we are inviting a lot of corporates that have been a part of the project, other corporates as well. We have, for example, BMW, Startup Garage coming in from Germany to talk a little bit about how they work with startups. And there are still, it's almost full, the event, actually, to be honest. We have 11 seats left, that's it. We have super discounted startup exhibition tickets. If you're interested in grabbing one, email me, because I have to leave very soon to fix with all of those things that comes with a large event. Okay, stina@thingsstockholm.com, and I hope to see you there. Thank you.
All right. Before we start with the main talks, we normally announce when people get funding, because it's kind of interesting. And what will happen otherwise in the community. One thing that was really cool was that, is there anybody working for Natural Cycles here? Well, they got funded with $30 million during the week, so that's a pretty cool thing. I guess it will grow a lot now. Are they situated over here? Or in the city center? I'm not really sure. Natural Cycles. All right. Fidesmo is another one that got funded. They got 10 million Swedish kroners. What they do, I actually met these guys. What they're doing is trying to make one chipset that you can have in a Visa card, for example, a credit card, but that can cover all kinds of chip technologies, so that instead of having, like, I have 10 different Visa cards and different cards here, I guess, they would combine it into one, and in the end, they would combine it into a thing you have in your hand, maybe. So that's a really cool idea, and they got 10 million kroners. Another company called AI Flow, I don't know them, but they got 5 million kroners. And finally, a company called Device Radio. I think these guys are based in Malmö, actually. They won the Swedish Embedded Award. I don't know these companies too well, but it's really cool to see Natural Cycles. Like $30 million is one of the big ones in Sweden. All right. Okay. Yeah. Cool. So we have 3 main talks, and the 2 lightning talks are ill right now. So we will just start with Åsa talking about light in transformation.
Thank you. Where is my presentation? Yes. Kan jag använda den eller ska jag? Which one?
I don't know which one it is.
Hello, everybody. I'm really excited to be here, and let me start with a question. How many of you stare at your phone in the evenings before you fall asleep? Honestly. Yeah, I think I do too. We started hearing a lot about how different kinds of light can have an effect on our health. And I'm going to talk about that from a few different perspectives. But first I'll start with my background. So I got interested in light a couple of years ago when I was working with mobile phones in Shenzhen, China. And I ended up in the electronics market looking for components for a product I was working on. And I ended up in the LED building, which is like Åhléns City or NK, but with only LEDs. How many of you have been there? A few, yes. So you know what I'm talking about. So you have the smallest components at the bottom, and the higher you get, the more conceptual it gets. And I realized, wow, lighting is huge, and I wanted to learn more. So I started thinking about designing luminaires. But then how do you control the luminaires? So I got interested in control systems. But then how do you know how to control? So I got interested in the psychology of light. So I decided to try and learn as much as possible. And I did a research project in psychology. Yes, but first let's talk about why I think light is so interesting. It's light in transformation, and right now from a technical perspective, I think that we're in the 3rd paradigm shift. Controlling fire, electrical light, and then LEDs. And it was awarded with the Nobel Prize in Physics a couple of years ago, and for me that's a milestone that it's quite useful, and the quality is increasing all the time. And at the same time, in 2001, scientists discovered the 3rd receptor in our eyes. So we have rods and cones, and then we also have a 3rd receptor that's connected to our circadian rhythm, and that's affecting our sleep-wake cycle. And we have a lot of that kind of light in daylight, but actually also in quite a few LEDs. And that's becoming really interesting this year, because now the Nobel Prize in Medicine was awarded for research in circadian rhythm. So that's why I think lighting is a very interesting topic right now. And when you ask psychologists about the 2 most important traits to predict a successful life, they all say self-control and intelligence. So far, no one has figured out how to make us more intelligent, but there are a lot of ways where we can improve our self-control, which is really important for us. And there are several examples of people who don't have so much self-control and where they lived successful lives, but they actually managed to ruin their whole career just by losing their self-control. Anders Borg, and a bit earlier, a French football player. So self-control is good for us, and we know that blue light affects us. I put this together, and asked, can blue light help us to improve our self-control? And there are two key people here. The first one is Professor Roy Baumeister. He thinks about the brain as a muscle that can be exhausted under hard work. So you basically use your self-control and then you need to restore your self-control again. And it's been the most, well, not important, but it's been like the key. He's been the key leader in self-control research for quite a while. But in 2010, Professor Veronica Job found that it's not only that your energy gets used up, it's also actually your beliefs about whether you think your energy will get used up or not. So I decided to replicate Veronica Job's research and added 2 lighting conditions, one where with normal LEDs and one where all the blue light had been filtered out to see could blue light have an effect on self-control. So I tested people in November, so there were hardly any daylight, and tested 82 people, and I randomly assigned them to the different rooms, and I did some self-assessments during the research period, which was 2 hours, and they thought that they were taking part in an office experiment, so they were reading books or doing their own work. And towards the end of the research, I wanted to make them lose their self-control, so I gave them an impossible task with an A4 sheet filled with nonsense text, and I asked them to count all the E's as fast as they could. It was a competition, and nobody killed me or hit me or anything. And then they got to do a performance test, and the errors they made was a sign of if they lost their self-control or not. And you could see that the people who believed in self-control as a limited resource were marginally affected, and they actually performed better in blue light. So I think that's quite interesting. And with this new knowledge about our physiology and our third receptor, this is just the beginning. In a couple of years, we're going to know so much more about the effect of light and the connection to our bodies and our behavior. If we have time, maybe by the end. Okay. Yeah. I mean 460 nanometers to 480 nanometers. Yeah, actual blue light. But in cold white light, you have a big portion of this. So another we know a little bit about how humans are affected by light, but we don't know everything. So we can also look at how spaces we designed can affect us, and we know that it affects us. And if we look at very young people, it has an effect on them too, and they're actually very sensitive to light. So this is a project we're working on now, and we've just completed the first part, and the task was to design intensive care unit in Helsingborg Hospital, because they're renovating the whole hospital, and see how we can improve it. So the challenge here is, first, these premature babies, they actually shouldn't be exposed to any light at all. But the staff need light to work, and the parents need to keep some kind of rhythm in their lives. And usually when you get into a neonatal care unit, the parents can be really stressed, and the baby is very sensitive, and the staff work a lot, 24/7. It's the same all the time. So the challenge here was they don't need, and the babies don't need any light. And if they're exposed to light, their senses can be overstimulated, which means that other senses don't develop as much. So it's big balance between how to satisfy the needs of everyone here. So our priority was, of course, the babies and also the staff when we designed this. And it's a hospital, so the opportunities to be very creative in this design was very limited, which was quite interesting because that made us focus much more on the control of the lights instead. So we got to work really closely with the staff. So we actually got to join them in their work, and they were very interested in lighting too. So they supported us by actually measuring light levels while they were working and we weren't there. So it's been a quite unique project for me to being able to work so closely to them. And also got to do a study visit in Oakland to a neonatal care unit. And I was shocked. And I realized that Swedish healthcare is actually pretty good. Especially in neonatal care. So we in Lund University, we got to do a prototype lab where we got to borrow all the equipment and install everything and actually try and build, which was really fun and something I don't get to do very often either. So we started calibrating the light and see when we have a light level outside, how does it look in the incubator for the baby. So the pink square is the incubator, and then we measure the light levels or the black circles, and we decided that the one that was good enough was the one with the star. So we always measured the star and inside the incubator during the work to see what kind of light levels you get, because there are a lot of rules on you need this kind of lux on this area for this kind of tasks, etc. So we needed to balance that. And we decided to do 5 different dynamic light scenes. So first we have the general lighting, and then we have night light, which is almost dark. And actually, let me move to this one. So it's as dark as possible, and outside this this room, the staff sit with a monitor, so they can monitor several babies. And so we needed to make sure that the contrast between their work and inside the room was not too big. And we wanted to keep it as dark as possible for the babies. And then we had the ambient lighting. So when the baby is with their parents and not in the incubator, we needed to remove all the blue light. So we didn't affect their circadian rhythm at all. And there is actually not so much research done here in this area, because I guess nobody really dares to try if you're doing something bad. So you could say that from week 28, the baby can stand 27 lux, which is a very low light level. But so we had 2 things to support the staff. So one of them was the focus light. It's a warm light, and we also tried to minimize blue light here. And it's like when they do observation, because a big part of the staff methodology was to observe the babies and respond to their needs by observation. And the other one was precision light, and we needed cool light when they were working with the needles, for example. And this is, then in these light scenes, the eyes always needs to be covered. And sometimes they also have a big blanket on top of the incubator to remove all the light. it's also interesting because the light that comes with the incubator is really, really strong. So it really doesn't go together with the needs of the baby. So we had almost to switch it off completely. Yeah. So that's where we are now, and it's going to be installed in February next year. And the challenge then will be to look, how can we add a timeline to this? Is there a typical way of working in each of these precision lights or focus light scenes, for example? So that's going to be really exciting to see how we can work with staff, because today we're not used to think about light as time-based. It's more, we set it to a scene and then we leave it there, unless we're in a theater. So that's going to be really interesting to see how we can add time, if we can add time to this. I'm not sure. We'll see. And am I talking too much? Okay, thank you. So a third project I wanted to talk about is that I did with 3 other lighting designers. And the challenge was to invite people into this park when it was dark. It's like a big black hole inside, so it gets pretty scary in the evenings, and people didn't dare to enter. So what could we do? And we did some research on this area. It's outside of Stockholm, and we found that during World War II, children used to run and hide when there were flight alarms in this particular area. And when you look at flight, they make quite interesting patterns, which we found really inspiring for this project. So from an experience design perspective, we set 3 different stages in this project. So can you see this? Or yeah. So you see the big black hole in the center and the 3 different stages, and then there's a street outside where that person is standing. I think if you can see, it's okay. So we set a little bit of drama here. So we wanted to invite people and then make them surprised and excited, and then make them feel safe so they dare to stay and walk around. And if you look at the physiology of our eyes, it's only in the very center of our eyes that we can see color, but in the peripheral vision we see contrasts. So we made the entrance a little bit wider by adding the white light at the ends of the entrance, so that you would see if someone would be walking there, so you would feel safe and get an overview, because that's something I feel is very important. And you have a little bit of color in the center. So when you get a little bit further in, you'll be surprised, because you'll see more colors, and you'll see at the far end of the park that something else is happening. So hopefully you'll get so surprised that you would want to continue inside. And then we wanted people to feel safe. And this is where the flight patterns come in. So we designed flight patterns on the big black hole. And the idea was to make sure that no one can actually walk here and surprise you. You would always see when someone is crossing one of these light beams. And we wanted to make it subtle, because now when you enter the park, you can still see the stars, but you feel safe at the same time. It was a temporary installation outside in Handen, Haninge. And so these are some of the projects I've been working on, and some examples of how humans are affected and can affect light too. And I think light is going to be more important in our lives and how we design everything, because a nice thing about light is that it's completely reversible. You don't make any permanent what do you call it? Permanent damage, or what you would call it, to your surroundings. It can all be reversed and redone again. And that's also interesting when you control light. So for me, these are some examples of how we can help people to get exposed to the right light at the right time. And that's what I want to do with my work. Thank you. Any questions? Oh.
Who was the customer for the park job, and what's the outcome of it? Did you get any feedback from?
Yes, it was Haninge Kommun. It was just a temporary light festival, very small. And some said that they wanted to make it a permanent installation, but I think maybe it's a little bit too colorful. But well, you would say no, yeah. But for Sweden.
Do you know the lux level in the womb? The natural exposure for babies?
Yeah, the lux level in the womb, it's actually not completely dark, and there is no blue light that gets in, but some infrared lights. Maybe you know exactly. Yeah. Yeah, it's not completely dark. Do you know? Oh, okay. I can find out.
So it's still expected to be practically zero compared to anything on the outside of the womb. On a bright summer day on the savannah.
Yeah.
I was just thinking on the neonatal, you said you're going to install it in February. Have you put sensors in the room as well, so you can use it for research going forward? You can see different results there, or do you trust that they will follow like a scheme that they will use these lights?
The question is if I put sensors in the neonatal room. There's going to be some sensors there. Not sure exactly. I mean, there's some sensors connected to the control system, and that's why we added the star where you can calibrate the light when you install it, because the room that we used is not exactly the same dimensions as the final room. But we hope to put more sensors in, but it's not decided exactly how we're going to do it. But I think we have such a good cooperation with the staff, so they'd be very open to discuss it. And that's also the interesting thing with the time-based solution, which is not so common. So we're just open. Yeah, of course we measure it. Yes. Yes, of course. Yeah. Sorry, what was the question? The question is why I choose to work with the neonatal care. So this was actually it's not research, it's an assignment that we've been working on. So it's a client. And what was the second question? What? Well, because this was a neonatal care unit, and the circadian rhythm in neonatal babies are developed quite late, so after week 28 or maybe even later. And even full-born babies don't have a very regular circadian rhythm, as all parents know. Yes?
Do we know why humans are sensitive to the blue light from an evolutionary perspective?
Evolutionary. Do we know why humans are affected by blue light from an evolutionary perspective? I don't know, but there is a big portion of blue light in daylight, so I would assume that that's relation, and I think why it's become so much in focus these days is because we have a lot of maybe cheaper LEDs which has a lot of blue light compared, and that's also a topic for when people talk about light pollution. And in big cities with a lot of LEDs, you can see that the birds change their circadian rhythm and stay more awake because they go to these light sources.
Has there been much interest in these light solutions in other andra kommuner? Du tror Helsingborg?
It's actually so new. We just completed it and it hasn't been installed yet. But yes, there is some interest from other parts and also in the US. So that's very exciting. Okay.
I have a last question.
Okay.
But I want to show when I installed this.
Mm-hmm.
If I can just. When I installed the computer, people were complaining that my screen was yellow, and that was because I'm using this. Does anybody know this application called Flux? Yes. It's I hate it because it's annoying, but it's probably good for me. But I don't recognize it. I'm just annoyed by the fact that it's yellow, but I guess it's good for me in the end.
So it's yellow because it's supposed to filter out the blue light.
No, it's hard to see on the video.
Yeah. I'd recommend everyone to use it anyway, even though you don't like it.
But it's good for me, but I appreciate the blue light to keep me awake.
Yeah, okay, that's true. Yeah, exactly. No, in the evening, yeah.
And I think Apple introduced it as well.
Yeah, it's on the computer too now if you update.
Really, I didn't know that.
Well, okay, one last.
Yeah, maybe the last.
Yes.
I'm studying lighting design.
Ah.
I've been to a lighting conference last week in Paris. There was one lecture about a guy who did research on himself, exposing himself to blue light before he went to sleep, or wearing yellow tone glasses. And he controlled this experiment. He did it for 1 year and did several scenarios. He controlled that with a watch, which controls the light level and blue under. And actually, what he discovered was nothing as just a psychological difference. So the watch was telling him that although he was exposed half an hour to blue light, like bright LED light, his sleeping rhythm was the same. So he felt that he was not that confident. That actually the watch or the results were the same, were hardly better than when he was exposed to orange light. So he questions this. So what do you think about that?
Well, I agree. I mean, if there's a lot of research that can say that if you're exposed to some kind of light, we can see an effect in your hormone levels. But even if you and me get the same effect on our hormone levels, I don't know if that affects me the same way as it affects you. So, and that's a little bit what I meant earlier, that the research in this area is still very new and there are so many things that we don't know yet. But we know that there's not as simple as, blue light, suppress melatonin, and you behave like this. We still don't know what the effect can cause in behavior. And maybe he drank more coffee than you and me. I don't know. Can be so many other things, because that's also why I think light research is so difficult, because it's impossible to track all the light one person is exposed to during the day. So it's really hard to isolate and make a real experiment, because you can't lock people in a room and expose them to the same light, because then they're going to feel bad for being locked up in a room. So, but I agree, it's very interesting. These kind of experiments are really interesting.
I mean, it was just one.
Yeah, but yes, definitely.
And you can't do a blind test. That's a big problem. You can take a bottle of Coke and Pepsi and remove the label and ask people which one is better. But you can't put someone in a room with blue light and yellow light and cover their eyes and ask if they feel better.
Yeah.
Because they will see that they're being tested and they know that they're blue or yellow.
Okay, Carolyn. Huh? Oh.
And it's very interesting because it shows that the natural circadian rhythm is actually 25 hours, which explains why we get later and later in the evening before we go to bed. So there's like natural biological reasons for why we are
Interesting. Ska vi...
Thank you, Åsa.
Thank you.
And then coming back to the question you asked in the beginning and Caroline's comment, what is the reason why I have to, when I go to bed, I have to take out my phone and like shine light right in my face before I go to bed, and then I kind of fall asleep. Maybe that's also a human trait, I don't know. But then I guess this like night shift and everything is important, but it's, you have to get adapted to it, I guess, to understand that you actually have to go to bed and you have to sleep and check out of, yeah. All right, next speaker is Malin, who will talk about connected textiles. All right.
Thank you. Can we take out the light in the room? Great. Oh, that's fine. I think that can be on.
Is that the PowerPoint you want?
Yes. No, that's the PowerPoint. Yeah. That looks good. And then,
How is it done in PowerPoint? This one, right?
yeah. And just make sure that there's
Do you have sound?
No, I don't want sound.
You don't want sound.
Yeah. Hello, everyone. Thank you for having me here. My name is Malin Bobeck Tada. It used to be only Malin Bobeck, but I got married this summer, and then we added Tada to our name. We just felt that that suited us. And I work as an artist in the textile and installation field. And I have specialized in weaving with optical fibers. So my work revolves around finding new ways of interaction. And through my interactive light-emitting installations, I invite people to experience new environments and find new ways of interacting with each other. And I weave my textiles with a combination of optical fibers, more traditional textile materials, and conductive yarns. And I make them come alive by connecting them to LEDs and different types of sensors. And I use my textiles to build unknown worlds where you can escape the reality and experiencing something new for a while. And my process reaches from concept building to designing the textile and all the weave bindings, and also building the physical installation. And today I would like to share with you some of my projects that I have made and how I work with turning light into a material. And I would like to start with this interactive fabric. So this is a sample piece that I have woven with optical fibers and different kinds of textile materials. And it's sound reactive. So it's connected to an Arduino and a little microphone. So if you can give it a hand, maybe you can see if it changes. Thank you. So this is my latest installation. It's called Tactile Refuge. And it's an installation where the viewer is the creator of its surroundings. And the piece consists of 6 fabric wings that is mounted on the walls and a hanging centerpiece that is hand-tufted and implanted with optical fibers. So the installation is floating in a dark, sheltered room. Let's see if we can start a little movie here. There. So the centerpiece is registering human touch. It's built like capacitive sensor. So it has a metal core, and the tufted surface is on the outside. And when people are touching the centerpiece and hugging it, the light patterns in the surrounded textiles intensifies. And the more people that interact with it together and communicate and create the space together, the stronger the light effects. And the inspiration from this came from the underwater worlds and the outer space, which I will probably never be able to reach. And I want to create spaces where people are kind of thrown out into a space that they haven't been before. And maybe find a new friend or communicate with someone that they haven't, that they don't know. And what I actually found with this piece is when people started to interact with the centerpiece and started hugging it, they also started to hug each other. So it created a very nice atmosphere in there. And the fabrics for this one is woven with Bogestunds väveri outside of Borås in Ulricehamn. And it consists of 12,000 meters of optical fibers and around 500 LEDs. So it's a lot of fabric. And it's been exhibited in Heimtex in Frankfurt and also in Hallwylska Museum. And right now it's in Paris in the Swedish Institute. So if you're on your way to Paris, check it out there. It's going to be there until January. And sometimes people ask me how I started, how I got the idea of weaving with the optical fibers. And for me, it's a very much a question of materials. And I love to calculate how I can combine different materials to create new effects and new textiles. And I found the optical fiber when I was a student at the Swedish School of Textiles in Borås. And it was also the same time I was going through major life changes. I just found out that I had breast cancer. And of course, this turned my entire life upside down. And I didn't really know how to continue. But I realized that working with what I loved was my best medicine. So during my illness, I felt that there was no tomorrow, no past. It was only now, and I needed to stay in the moment to be able to continue my day. And being forced to stay in the present awoken my lust for creating things just for the sake of creating and not just having a certain outcome. And I was studying textile design, and that was very based on giving results at the end. But when I found my new way of thinking at life, a new way of working, it gave me much more lust to work with the materials. And experimenting with the optical fiber just kept me going, and it was the right media for me to give my creative side a spark. And today I am free of the cancer, and I'm taking my learnings with me. And when I finished school, I had a new way of looking at life. I was taking one moment at a time, and I wanted to create new things. And I had an idea of the optical fiber. I had a project I wanted to make, and I wanted to create a fabric that could react to touch. And I had no idea how that was going to be possible, but I spent all of 2015 to figure it out. And the result was this. There should be a movie there. There we go. So this project is called Those Who Affected Me. And it's an interactive light-emitting textile installation that people can touch and affect its appearance. And it reacts by sending colorful ripples up and down the fabric. And it's a four-wing structure that is exhibited in a mirrored room, so it multiplies in infinity. And the textile is woven with optical fibers and more traditional textile materials and conductive yarn. And it's the spaces where you saw people touch there. That's the space where the conductive yarn is woven into the fabric. And then the fabric is mounted to around 500 LEDs and connected to capacitive sensors. And as I said, the installation is called Those Who Affected Me. And I see it as an abstract self-portrait, reflecting other people's impact on myself. And without the people around me, I wouldn't be here today. My family and my friends are creating me every moment. And the doctors and nurses that took care of me during my illness also meant a lot to me. And without their help and knowledge, I wouldn't be here today. So this is a tribute to all the people in my life. And the sculpture itself is 2.5 meters in diameter and 1.5 meters tall. And this brings me to the current project I am working on. It's an installation that has the working name Facette. And I'm creating this project together with two friends, Björn Albin, who is a 3D animator, and Jonas Johansson, who's a designer and technical genius. And the focus point for this project is to push the boundaries of what is real and what is fiction. So we're just in the starting point for this project, so this is more of mood board sketches. But the end result will be an interactive installation that also has a layer of augmented reality on top of it. So it will be consisting of several parts in different spaces that you can interact with just by touching them and see the physical change in the room. But you can also choose to wear HoloLens by Microsoft. And when you enter the room with the HoloLens, you will also get holographic animations coming into your field of vision when you're interacting with the sculpture and in the installations. And our hope is to also be able to create a space where people can choose if they want to experience the analog part of it or the digital and the analog. And that the people who are not wearing the HoloLens also will be able to start animations for the people who are actually wearing the headset. So we're hoping to create an atmosphere where people start to interact with each other more and give each other experiences. And in that way also be a part of the art, become performance actors themselves. This is another of the sketches. So there will be hopefully several rooms or several spaces that people can enter and interact with. But this is a project that will have a long way until it's done, so it will probably be in the next fall or winter. Then you can come and experience it. And my production process is very different depending on where I am in the project frame. But for me, the textile qualities in the fabrics are equally as important as that they actually light up and can be changed or interact with. And I combine the optical fibers with the traditional textile materials to create more tactile surfaces. And since we as humans are so used to fabrics and textile, we have it around ourselves 24 hours of the day almost. We wear it, we sleep in it, we dry ourselves after the shower with a towel. So it's so familiar. It also becomes a very natural surface to want to touch. So the tactile surfaces on my pieces are a very important part of communicating with the audience or with the participatory, the people who interact with it. And the optical fibers I use are not at all made for weaving. They're traditionally made for the lighting industry. And they transport the light from one end to another. And they're made to give as little loss of the light as possible. So they are basically transparent until the end of the fiber. But I create special weave bindings that make the fiber crack a little bit, because when they're woven into a fabric, they flow like this a little bit. And that cracks the surface and lets the light come out on the side of the fiber as well. And I normally use addressable LED pixels, RGB or RGBW. That's what I have used in this piece and all of the other piece I've shown you as well. And to be able to mount them to the LEDs, I 3D printed a little mounting piece, because there's no finished piece that you can buy that will mount optical fibers to a specific kind of LED. So it was a little bit of engineering job. And I often start my project with hand loom and prototyping the different materials and see how the optical fiber will shine more or less in different kinds of weave bindings. But the bigger pieces I create are woven on a jacquard loom together with the weaving factories. And I have a little film here of how it looks. So it's actually a 2 stories high jacquard machine in a massive weaving factory. So it's everything from using this basic hand loom with 1s and 0s, making the threads go up or down until it's produced in this jacquard machine. And of course, there's also some programming involved in creating the pieces I make. And I'm not a programmer, so I'm very glad that I have help from different technicians to help me to program my pieces. But I usually use different kinds of Arduino-based controls to create the effects that I want, and also the different kinds of sensors for interacting with the piece. And when you have a fabric that is connected to an Arduino and also connected to the internet. You can create many different kinds of expressions, and you can give information, but you can also receive information. It can sense how warm it is in a room, or it can sense how many people is walking on a carpet, and so on. And it can also connect physical space in different parts of the world by having one piece as a receiver and one piece as a sender. So there are many different things you can make with textiles like this. Thank you for listening. Yes? I think for me, it has a sense of change, that it can change over time. And that gives something, a more sense of being alive, or having a pulse, if you would call it that. And also for me, it's very much about having people interacting with it, so that they can decide, they can understand that they can interact with the art and also affect it and make it come alive themselves. So I think it also creates some kind of magic, because you don't expect a fabric to light up. So it gives a sense of not really realizing what's going on. Yeah. Yeah? So the question was how I source the fiber, and if I get any limitations in my projects, if it's economical or practical or power source. So the fibers I buy from the delivery in China, and they come on a roll. So I just use them as, instead of a yarn, putting them into the weaving machine. And they're not super expensive. I mean, it's not as cheap as a regular yarn, but it's not super expensive. There's also different types of fiber. There is cheaper ones that is good for smaller projects, but it's not strong enough to be woven into a fabric. So I use the more expensive one, but that has the better quality. And the limitations in my projects, I think I'm the biggest limiter. Partly because of my own ways of thinking how it should be, and just putting myself in difficult thinking patterns. But when it comes to the practical things, I would say there's always things that comes up that I can never know in beforehand. Like in this project, we were just about to show it for the first time in the art museum in Gothenburg, and just a couple of days before, we realized that there is a small electrical current that is actually going out to the steel skeleton of the sculpture. So we're like, oh shit, how are we going to do this? If people walk up to it and get electrical shock from it. It's not it's not the what we were aiming for. So we needed to solve it by actually leading the current back to ground through a cable. So it usually solves, not itself, but with talented people around me, can solve the electrical problems. And yeah, I solved the hardware, so to speak. Yeah. Do I fuse the fibers together, or do I connect them separately? I glue them in bundles, and I actually have small samples here. That you can either come and look at, or I can send it around to you. And this is run by just a regular power bank that you charge your phone with. And here you can also see how I connect the optical fibers with LEDs. So I glue them in straws that has a good diameter for the LED, and then I connect them with the 3D printed little mount thingy that is specially designed for this. And this piece is the same fabric that is in the project that I just showed, and it has the conductive yarn on the surface here. So when you touch it, it will change color. So you can come and look at these in the break. Anyone else? Yeah.
How long fibers can you sew into, if you've got already fabric? Because the light, since it escapes into every, this basically attenuates with length as opposed to the limit.
Yeah. So the question was, how long fibers can I weave into the textile? And that depends on what kind of weave bindings I use. Because if I have tighter weave bindings, it will go more like this. But if I have looser ones, it will go more like that. And it's really, you have to trial and error, see how long it will let the light travel. But what I do is that I also put it in the weft of the fabric. So the warp is what goes through the machine. That can be 20,000 meters long. But the weft is put sideways, and that is around 160 meters wide. So it's usually not a problem, but it really depends on if I accidentally crack the fiber because I made too tight weave bindings. Or if I just make too loose weave bindings, they will just be transparent and not shine on the surface of it. Yep. So if it's too loose, can I punch it and it will become more luminescent on the side? Yes, that is a possibility. Actually, if I scratch it with a razor or something, it can create really nice effects. But the problem when I weave it into a fabric is that it also has all these other threads that I will cut off if I do that. It's a fine line between different problems that can occur. There is actually optical fibers that is already cracked with like in the core of the optical fiber, but they are too weak to be put into the machine because the machine is pretty tough. on the material. Yeah. How I create the skeletons for the sculptures. That is also very much a trial and error. This skeleton, let's see if we can put it back to the... This is has a cylinder in the middle that is made out of steel with a lot of holes in it, and then all of the wings here have 8 steel rods that is going through the steel cylinder. So in the middle is very much like a plockepinn, is like just big mess of steel rods, and then there's a hemisphere underneath that just covers all the electronics and everything that is inside of it.
Should we take the rest of the questions in the break maybe?
Yeah, thank you.
Okay, cool. All right. Engineering light.
Okay, thank you. Thank you very much. Sorry for being late. Nice and interesting discussions here. Thank you for giving me the opportunity to be here today. My name is Lars Rymell. I'm actually a consultant working with optical design, and I work with a company called Eclipse. I will say a little bit about that, but not that much. I think it's very nice to be here today, and I've had 2 really interesting talks. These talks have been from not from the same area as me. I'm more from the technical area because I'm a physicist. So my talk will be a little bit more from the physics point of view and technical point of view. But I really enjoy this mix when you meet people from other areas. That's what makes my work very interesting. And I've been working with optics for 20 years, something like that. I started as a laser physicist, but then I've been working with optics and photonics for many years. I will be talking about engineering light. It's not that, it will be not that much engineering, but a little bit. I want not talk a lot about our company, but I have to say some things. It's not a selling presentation. But we are consultants working in optical design. We were 5 people starting it 3.5 years ago, and now we are 14. And we are only optical designers, everyone. 12 PhDs, so it's lots of academia in the group, but it's also a lot of product experience. We are product developers. We have been working a lot with developing products, optics for products, lots of consumer products and such things. We have offices in Stockholm and Malmö, and we work not only with lighting that we will talk today, we work also with cameras, sensors, everything that has to do with light. So light is my passion, and I'm an evangelist for light, so I really enjoy being here today. What we do then, just a few things that we have done, just to show you a little bit of our areas. We work with a lot with automotive. We work with active safety and such things. We work with cameras and different sensor systems for autonomous drive and such things. But we also work with consumer products. So actually we have made this illumination in Husqvarna's latest sewing machine. So that was nice to do. But we also work with energy environment, solar power. This is a solar parabola from Cleanergy in Gothenburg, where they have a 9-meter diameter solar parabola that they focus light onto a starting motor actually, and generating energy that way. And we have lots of life science. We work with microscopy and illumination in microscopy. And then there is really technical illumination. You need so much light in that place, and then we calculate that. So that's all about Eclipse. We heard today interesting talks, and we have heard this before. We heard this about the blue LED. And for me, it's really the revolution of lighting. That's year 0 for me. 1994 or something like that, when Professor Nakamura and friends started to develop this blue LED. Actually, I'm so old that I worked in a time where there was almost no blue LEDs and there were no white LEDs. So, of course, the first years it was very weak, this LED. So when I started to working with blue LEDs, you could have it for indicators in mobile phones. You remember the time when you didn't have a touchpad, you had keypads. Putting blue LEDs there. That's when I started working with LEDs. And then, of course, you could see how the development came. It started with mobile phones, and then we started to get, of course, this is red light, but still, we started to get LEDs into automotive. This is a gearbox. And then later on, when it becomes cheaper, you could have it in consumer appliances like dishwashers and such things, but the light was so weak then, so you couldn't use it for really illuminating things. Actually, I remember sitting calculating for a flash for a mobile phone, and we had 6 or 7 white LEDs, and we still couldn't get enough light to use it as a flash. It was really ridiculous. So, and then if someone told me then in a few years you can have it in a car as a headlight, I wouldn't believe them. So it's really been a revolution. Of course, when you talk of indoor lighting, where you use LEDs, I think it was a quite slow start, because this was the old lamp and this was the new lamp. You still have, of course, you had LEDs, but you didn't use the potential in an LED. You put them in the same armature and the same things. Of course, it was efficient, but it was quite blue, and you didn't use it for what it could be used for. So it took some time. So this was early after the millennium shift that they started to do this. But then suddenly something happens. And we have heard a bit about this before, but of course, where you can do much more with your indoor lighting. And this is actually IKEA Flowalt, I think it's called, where you have illuminated panels, and you can do so much more. So you can really, it would it will really make a big shift in making light indoors. Sorry for my English sometimes. So that's interesting, of course, but also making, of course, the changing the colors. This is Philips Hue, came some years ago, and we have heard this for blue light and red light. Actually, I have at my home, I have this blue light in the morning and red light in the evening, and I think it's okay, but maybe it's more in my own brain. I think it's okay for me. But of course, then you can start to use it in another way. Actually, these types of panels, we have worked a little bit with that at our company too, and you can do quite funny things, because what these panels are basically, it's just a glass plate, and you put a LED strip in one end, and the light is transferred into the glass plate and leaks out, approximately the same as your optical fibers. And we try this by putting light into a glass plate and writing at the same time, and then suddenly it looks like your text is suddenly glowing from this glass plate. Sorry? No, that is frosted, but that's not frosted. No, but you have a pen, and when you write on it, you change it leaks out the lights. So but it's basically the same way that these are working. Of course, it's not only humans that are affected by light. Plants are affected by light. I just want to put that out too. So this is a company in Gothenburg, Heliospectra. They work with designing light for greenhouses. And by changing the wavelength of the light, you can make the plants grow faster. They were quite famous some years ago because their systems were used for growing cannabis, actually, but you can use it for other things too. And that's very interesting. Very interesting science is done there too, and see what you can do by changing the properties of the light and what it makes for growing. And for the future, since we have to grow more plants because we need more to eat for everyone, so it's very interesting to this science that is done in that area. So that's indoor lighting. Of course, there is outdoor lighting too. We have heard, I also have interesting in this light pollution. And of course, LED is responsible for light pollution, but if it's designed on the right way, you can actually, I think you could decrease light pollution too. Because when you start with this first traffic or street lights, you really didn't use it in the right way. That's why you really need an optical designer to take care of the light and really use the light in the right way, so the light goes to the road and not up in the sky. So that's of course LEDs will bring more pollution, but if you do it in the right way, I think you can decrease it. And then of course what we have been working a lot with is illumination for vehicles, automotive. And you become quite a nerd. My colleagues and I, we go out for lunch and we see a new car and everyone goes, "Oh, how is the headlight designed?" And suddenly the alarm goes off and you have to run away. But it's really interesting to see and see how the different companies getting better and better. So and this is actually a Mercedes, and if you start by the headlights, it's really nice design. Now you have this multi-beam LEDs. I think they have 84 LEDs in their headlight, and you can turn them on and off independently. And that means that you can, when you have your strong beam on, you can actually find areas that you don't have the strong light. So you can still have strong illumination out on the side, but you don't dazzle or blind the vehicle you meet. So that's really nice technology, and I think Mercedes was the first company working with that. And then of course it's design too. You can use this lighting to really diversify. Why should I buy a BMW or why should I buy a Volvo? Because it looks different, but every car looks the same. But if you really, I think making the illumination and the lighting in the right way, you can really use that for improving your brand too. So that's also interesting. So that's an interesting area. So how do you then, if you come to this nice headlights, how do you do this in an engineering type of way then? And that's where I've been working a lot with, and that's actually designing good light, as we call it, light simulation. And light simulation, we talked about trial and error before, but we really think that it can be good to calculate a little bit sometimes too. So we work with simulating our optical systems. So this is just an image of an LED, just an LED illuminating a surface. So this is actually simulated illumination, which we have used with ray tracing software. And this is the same as a photograph. Just ignore this stripe, it's just a measuring probe there. So it's actually a photo showing the same pattern approximately as the simulated one. And this is a very simple example, but that's what we do all the days, sitting with computers and trying to optimize systems before making prototypes and before building the systems. We think you can save time by simulating to start with. Of course, then you have to test the things too, but we do lots of simulations. And one example, what we do a lot is getting even illumination. And then if I come back to these headlights, we see again, this is the Mercedes headlight. This is a headlight of another car maker. I won't say what, but I really like this nice design here, and I don't really like that that design. I don't want to see the LEDs actually in that way. And another nice feature for Mercedes is, of course, this is the indicator when you go turning around. People don't use that anymore, but really when you use, you can indicate when you're going left or right. It's a nice thing, and it's yellow. But actually, if you don't use it, like many people do, it's white. So you can really change the color of this stripe. So then it's a position light. But it's quite even and very nice illumination, and that's actually lots of projects we work with is achieving nice illumination. And then we also use ray tracing software. So this is just an image from a ray tracing we have done, putting different LEDs. And what we want to have is a very nice illumination up here where you don't see the LEDs. And of course, we try to mix the light as much as possible. And then you can do with, in this case, with a light guide here and a diffusing surface or scattering surface. And that is actually what we simulate how the illumination becomes then. And in some ways, you don't really need this light guide. It's just a good material having a scattering surface. So this is just a prototype we made in our lab just to look at how good you can get. And actually, this is only LEDs and a scattering surface, and it can get it quite nice, actually. So that's what we work with a lot. The last really example on that, which is a really more, if I talk about this one, that can be indicators for some kind of appliances, something that you would like to have look nice. It can be your TV keypad or something that should look nice. But in some cases, you really need very good illumination. And this is an example of a company, Provfoto. I don't know if you know it. They make professional flashes for professional photography. If you look at top model, it's their flashes they use actually usually. Provfoto, they are. If you need a flash, you need to have really. You need much light and you need a very even light. So that's very difficult to achieve in some ways. So then you really need to do these simulations. So this is a simulation we have done together with Provfoto of the lens for their new flash A1 that they released, I think it was 3 weeks ago or something like that. And my colleague Olof actually made this lens, and he's very, very happy with that. And I think they were happy with it too. But that's also very interesting, because if you're talking with this type of photographers, they want to have even light, they want to have much light, and they want to have a little bit scratchy light. And that's difficult for me as a physicist. What's a little bit scratchy? And sometimes they say in Swedish, krispigt ljus. And we want to have figures, we want to have specifications. It's very difficult to really to understand sometimes. But it's once again this, when you meet artists together with technicians, it's very interesting, and see if you can find something together. But this was a very nice project I'm working with. So actually that was all I was going to say today. So I'm happy to answer any questions, and yeah. Yeah. In life science, we had a question of spectrometers. Yes, we work a lot with spectrometers, especially for life science and such applications. Yeah. Yes. Oh, legs. No. Ask about a daylight simulator that you can have in a closed confinement in your cellar or something like that, and really simulate clouds passing by and such things. No, I haven't heard about that, but it sounds very interesting. But it must be some kind of, yeah, you must have some moving parts, I would say, with some filters going around. But it would be very interesting to know more. Yes? Yeah.
This thing called number called color rendition index, which you care about if you care about colors. You didn't really mention the färgåtergivning, how the spectrum of LED lights and such. Is that, how does that enter your work?
Yes, of course, that's also very interesting to see. And it's also actually. I shouldn't really answer these questions. These are more my expert colleagues, but we work a lot with defining the exact color of things, and of course, for automotive, for instance, it's defining what is the right yellow light for an indicator, for instance. So it's very interesting to be able to measure and defining that you get the right color. So, and that's of course when you also work with sensors and measuring color. So we work a lot with defining such things too, yes. And for this sewing machine, it was very interesting to get the right working environment. If you're working with different types of fabrics, you must have light that really works with the fabric too. So you can't use, you have to think about what color temperature you have on the illuminated light there too. So it's a lot of that decisions too. Yes, right. Yeah, I get the question when artists ask for crispy juice, what they are after. Beats me actually. I think it's sorry, some kind of contrast maybe. I don't know, or if it's more it's getting sharpness in a little bit. Not that even light that we want to have. Maybe they want to have a little bit structure in the light. I don't know. Maybe, but yeah, I'm not really sure. Yes. Mainly as consultants, but when we have spare time, we do some innovation by ourselves. But it's when we don't have any customers, we have to do something, and we are quite an innovative people. But then of course we start something, and then you get an assignment, and then but we do a little bit by the side. Yes. Yes.
As you're working for car illumination and also street illumination, do you think street light is something for the future, or can we just, as the cars have such good lighting, can we just illuminate the street lights and just have it not for cars but maybe for pedestrians, and then we don't have that much light pollution anymore?
Yeah, the question was if we can skip the street lights and for cars and only have illumination from cars instead, and have street lights for pedestrians and such things. I think that's a quite interesting idea, actually. They already talk about this when the car comes into the town. You turn down. You have sensors, so you turn down the street lights, or on the other hand, maybe turn down the illumination in the cars when you come into a town. So I think that might be a good idea, because maybe you don't need that anymore for larger roads. But of course, for the pedestrians and cyclists and all those things, then you have to have light to make you feel safe and such things too. Yeah. Yeah, I think that's a very interesting question. The question was vertical farming in urban areas. I think that can be really good to have this type of light systems for that. Actually, all those things I've shown here, we haven't done. This was just examples. Heliospectra, we have worked with, but they have very clever guys themselves, so they have done lots of these things. And I think they're looking into this thing, and that's really interesting for the future, and I think LED light is really good for that. Yes? No. I'm getting old and cynical. No, everything good has already been invented. The question was, is there some disruptive thing that come like the blue light? No, of course there will be. But I don't really see a change now. Of course, there are happening lots of things, but not that disruptive as the blue LED was. I don't see it now. Yes. Yeah. Yeah, we'll say. Yeah.
Maybe we can take the questions after the rest of the talk, because there is more. All right. Thank you. We had 2 lightning talks. It was you and who else was it? Right. Yeah. Did you have any slides you wanted to show? But we'll just find it. All right. Okay. And you had a video and it's set up? All right. Cool. Take it away.
Okay. Chris Forsberg from Society. We're an IT consultant company, but we like this stuff as well. I want to say I think it's really cool to be here. I was talking to Sune like 3 years ago when he was starting this up, and I think what you guys are doing here is completely awesome. So, I mean, you should give yourself a hand. I think it's so cool what you're doing here. So, anyway, so I just want to talk a bit about one project that we did for Philips. So I will show a video first, and then I will make some comments. Do we have sound? Or no?
Simply, it is smart lighting that gives you wireless control and lets you take your lighting game. Put it simply, it is smart lighting that gives you wireless control and lets you take your lighting game to a whole new level. Now, as far as how the Hue system works, you have the lights, which are smart and energy efficient LEDs that deliver bright and beautiful light. You have the bridge, which is the heart of the Philips Hue system and allows you to talk to and control your Hue lights over Wi-Fi. From there, you have the Philips Hue app, which is the simplest way to set brightness, create timers.
So we were not involved in the development of the lights, but we did this app. Our Dutch team did the app.
Change colors, play with scenes, or you can even log in online and control your Philips Hue system no matter where you are in the world.
But the more important thing, and that's what I wanted to say a few words about, was that we put together their APIs. And I don't know, how many have played around with their open APIs? A few of you? Cool. I suggest you should do it. It's really cool if you have the lights. I mean, you just sign up, you get an API key, and you can do anything. And it has, created a real ecosystem of different apps. So first, some uses, what you can use it for.
She was so startled that she dived down under the water.
When you're reading fairy tales, or when the cake is ready, the light is flashing. And this is connected to a weather service, so you can see when you need to bring the umbrella. And the husband who is taking pictures of flowers and then adapting the light when the wife is coming down to dinner. And the father making some more Christmas feeling.
Like this?
Playing around with the camera. And here's a deaf girl using it as a doorbell.
All right,
so before I show this guy, he's a cinematographer. I almost got that word right. For one of the what's it called, the movie, one of the scary movie, now I forgot the name. Do you remember the name, Karina? Abnormal Activity, sorry. One of the films, and he was asked by Philips to put together something for Halloween. So what he did was he was using some of these third-party apps and to play
Philips
around.
Hue A19 bulbs in these hanging lamps. Underneath the cabinets, we did some Philips Hue light strip pluses. There's a lot of third-party apps that work with the Philips Hue line. One of them is Hue Halloween, and it's got a lot of preset things in it. So we have this hallway here. Say you're having a Halloween party and you want to create kind of a haunted house vibe with some really freaky, scary ambiance. So I started, we threw this desk over, set the lamp down. We rigged up a couple of Philips Hue BR30 bulbs. We opened up the Hue Disco app. I love those scenes in horror films where the lights are flickering a little bit.
So what is Hue?
Okay, so what we did the apps and we did also the API. I also want to mention that we helped Philips. I'm not very good with these things, but they have some pain relief devices that we also did the apps for. So we are doing it. So I'm an architect, so I come from the back end, so to say. So if you guys need somebody to connect to back-end systems and all the boring stuff, digital platforms, you can call me. I'm part of a new team at Society who is working with innovation and also want to connect with the startup community. So Marley, for example, can you get up? She is the one who you should talk to if you want to get in contact with us. And then we have another colleague, Carolina, here, who is working as a product manager. So for one thing, last thing I want to mention, we're working with the Scandinavian Airlines in the innovation lab there. I'm the architect and Carolina is the product owner. So they are doing some fun stuff. For example, this is a button. So if you have an idea what this SAS button should do, please come to me and tell me. That's it. Yes? Turn off the lights. In the plane? Go home button. Okay, you should go home now. Okay, yeah, that's good. Any more questions? Okay, good. I will be here. Thank you.
I'm not really a math teacher. Maybe you can help me get the display going.
It should be alright. It's coming.
Sorry? Yeah. Okay. Let's maximize this. Something like that. Okay. Hello everyone. Lovely evening. I wasn't planning on doing a talk, so I did spontaneous. So my name is Lennart Liberg. Software developer. There's been a lot of talk about artificial lighting tonight, so I thought I'd contrast that with there's actually a whole lot of natural lighting around us. I've had this idea for years, and I recently were exchanging ideas with a friend, and we realized we'd had the same idea: heliostats, shining light into people's homes. For those of you who don't know what a heliostat is, it's basically something that tracks the sun. I used to live in this ground floor in my grandma's house, and it only had morning light, but all the garden was lit. So I took this big mirror out, and I positioned it in the garden, and had a square meter of sunlight into the ceiling of my room, and I could not believe how bright my room got. So since then, I've had this kind of idea project I've never got around to until I spoke with my friend. And then he showed me there's actually an Indiegogo campaign that they're gonna deliver in December. They're called Kaya, and they're kind of doing the same thing, which I found really interesting. The diameter of the mirror is like 38 centimeters or so. I don't know how it works. They don't really say. So hopefully they deliver. Maybe I'll get one, or maybe it won't work. No idea. It's gonna be interesting at least, and it's really interesting for me that I've like had this nagging idea for a long time that someone is doing it. There's also I also found this guy that was basically building his own thing in a more static way. I'll kill that one. So maybe this will be something I get around to doing. I think it's super cool. For those of you who like numbers, I was like looking through the brightness of the sun numbers the other day, and so this will be a short back of the envelope thing. So the sun, the intensity is 100,000 lux. If you capture that on 1 square meter, the amount of light is 100,000 lumen, which is the number you will read on the light bulb when you buy it at IKEA or something. So 100,000 lumen, that's 100 light bulbs if you buy a strong one. A strong one is 1,000 lumens. So with 1 square meter of mirrored sunlight, you could put the light of 100 pretty strong light bulbs into your home. Yeah, that was pretty much it. I'm still excited about the thought. Stuart. Yeah, they have. Right, thank you. Oh, yeah. Oh, they're Norwegians. They built like a mirror array. So there's this village in a fjord, and in the winter they don't get any sunlight basically because they're in the bottom of a valley. So they built this array on the mountainside, and there's this like one spot in the village you can go stand in the sunlight. Yeah. Yeah. There's also natural lighting. So cool. Yeah. Yeah. Anyway, thank you.
Thank you. We're coming back to the last. Is this on, or do we have to turn it on? Oh, there it is. Yeah. These were the talks. I'm happy that we got 2 lightning talks. That's super interesting. What's happening next? Somebody asked why we didn't do this for a long time, and that was because of paternity leave. Next time the meetup will probably be in January because December is close and now Christmas is coming. So we are happy to get suggestions for new themes, which could be anything. We've done 14 events so far by now. So please come with new suggestions. You can send it to anyone. Do we have our email addresses out there? I think the meetup would have some channel, right? That you can post stuff on the channel. I saw that. You can have like a thread on the meetup, yeah. So on the meetup.com you can post stuff. That's it for tonight. Thanks for coming and see you in January again.